Imagine a logistics network operating at peak efficiency. Robotic arms pull inventory in perfect synchronization, and parcels glide along optimized routes at breakneck speeds. DHL invested millions to bring this vision to life. As a global leader in logistics, they deployed state-of-the-art warehouse robotics and advanced AI routing systems across their global operations. The strategy aimed for massive gains. By injecting this level of intelligence into the supply chain, DHL intended to slash operating costs, eliminate waste, and push delivery speeds to their physical limits. On paper, the rollout was flawless, but in practice, the performance gains were localized and inconsistent. Instead of streamlining the flow, implementation costs rose as the new technology created unexpected friction within the existing daily workflow. This creates a difficult mystery. Why would dropping the smartest, fastest technology available into a logistics network cause the entire system to stumble? To find the source of the friction, we have to follow the physical journey of a single package as it enters the DHL ecosystem. Deep inside the facility, newly installed robotic systems stand ready. They process goods at speeds that far surpass the physical limits of a human worker. This diagram reveals the breakdown. Here at the end, you have a high-speed robotic node, but look at the steps leading into it. Those are human workers using manual sorting methods to feed the line. The high-speed machines are constantly starving for work. Packages pile up at the transition point. This creates a hurry-up-and-wait dynamic that negates the multi-million-dollar speed of the robotics. This is siloed automation. The advanced tools work perfectly in isolation, yet they clash with the physical environment around them. Optimizing an isolated step at the end of the line does not cure a bottleneck. It simply shifts the point of failure to a different part of the chain. The friction extended beyond the warehouse floor and into the digital realm of DHL's AI routing systems. This software calculates millions of variables in real time to generate hyper-efficient delivery plans for drivers on the ground. However, DHL layered this cutting-edge AI on top of legacy IT infrastructure, systems built decades ago that operate on a completely different logic. Optimization data became trapped in translation. The AI's routing plans were effectively useless because the legacy systems could not process or execute the new commands. The final point of failure was the human workforce expected to use these tools. Workers who were untrained in these digital workflows often ignored the AI's insights. They relied instead on manual overrides and old habits to manage their routes. The AI system knew exactly what to do, but the broader organization lacked the capability to act on that knowledge. The DHL case reveals the true difficulty of technological integration. The robotics and AI performed their individual tasks, yet the system as a whole failed to improve because the connections between those tasks were broken. This is the trap of partial transformation. It is the assumption that change can happen in isolated pockets rather than across a synchronized ecosystem. Applying automation to an outdated workflow without redesigning the underlying process is an expensive way to accelerate friction. Real operational transformation requires three things: system interoperability, end-to-end process alignment, and rigorous workforce development. New technology must be deliberately structured to align with and elevate human workflows. Attempting to blindly replace those workflows usually results in systemic failure. Logistics relies on end-to-end thinking. The connections between nodes matter more than the efficiency of any single node. Digital transformation requires a total redesign of an organization's operational reality. It is a structural evolution that must reach every corner of the system to succeed.